Dear students, today we shall be discussing diffraction due to n slits. This will be largely based on your previous knowledge, right? Suppose you have n number of slits in this manner. All of them are illuminated by a common light source, right? E is the width of each slit and D is the distance between them. So since it is Fraunhofer diffraction, we shall place a convex lens, a collimating lens, and after that there is the screen, right? The rays of light meet at a point like this, giving one of the points, say P1, right? Now on account of diffraction, since the rays of light bend, they keep on meeting at other points on the screen, on the upper side and on the lower side, right? So we can show it like this. So this is some another point P2. Now we know that the path difference between any two waves from the adjacent slits is calculated in this way. I will not repeat those calculations. I will write certain expressions directly today because you have already done it many times. So path difference is actually E plus D sine theta. And the consequent phase difference phi is equal to 2 pi by lambda E plus D sine theta. Or phi is equal to 2 beta, where we have put beta equal to pi by lambda E plus D sine theta. Or beta is equal to phi by 2. You have also learned that the resultant amplitude at a point on the screen due to diffraction from a single slit is given by A is equal to A naught sine alpha by alpha. And if you want to recall, this was the single slit and this was the wavefront coming from it. And we have assumed that every point on the wavefront is a fresh source of disturbance. Now, if there are n disturbances, and A is the amplitude of each, then the total amplitude A naught, this A naught is equal to NA. And moreover, the phase difference between any two rays from the wavefront was equal to alpha. So the resultant amplitude was A equal to A naught times sine alpha by alpha. Today you have to find what is the intensity on the screen due to diffraction from n number of slits. For that you may need to write what are the wave equations of the waves from different slits. Suppose they are written as y1 is equal to A cos omega t, y2 is equal to A cos omega t plus phi, where phi is the phase difference. Y3 similarly is equal to the same thing, and the total disturbance y is equal to y1 plus y2 plus y3 plus so on up to n terms. And what is n? This n is the number of slits. Now we are basically interested in finding the intensity at a given point due to these n number of slits, for which we shall be squaring this y term. So the resultant intensity will be proportional to this y square. That will be given by, of course, A square will come out as common. You will be left with cos omega t plus phi plus so on up to n number of terms square, right? And if you solve it using the existing trigonometric equations, formulas, you get this is equal to 1 minus cos n phi by 1 minus cos phi, right? So for this A, you can substitute the value that it is A naught square sine square alpha by alpha square. For this, you can write that 1 minus cos of theta is equal to twice sine square theta by 2, right? So this is twice sine square n phi by 2 by twice sine square phi by 2, right? So this is, if you recall, what is this phi by 2? This phi by 2 is actually beta, So this is a naught square sine square alpha by alpha square. 2 and 2 will go. You are left with sine square n beta by sine square beta. This is the resultant expression of intensity due to n slits on a screen. But you need to find the maxima and minima. You need to find the conditions for maxima and for the minima. Right? Now, for maxima first, see if we assume that sine n beta is 0 and sine beta is 0, right? What does that give us? That gives us a condition of 0 by 0, a condition of indeterminacy. So we are not able to find out what exactly is going to happen. But an alternate way of approaching that thing is that we may choose to look for the change in sine square n beta and change in sine square beta. So we may write it like this, that sine square n beta by sine beta is equal to limit, suppose beta tends to n pi, d by d beta of sine n beta by d by d beta of sine beta, right? Let us choose a limit of this fraction, sine n beta and divided by sine beta, when beta tends to n pi, right? Because we are not able to make out anything from the condition of indeterminacy. Therefore, we are looking for the change in sine n beta and sine beta, right? Now we know that differentiation of sine is cos, so n factor will come out, right? It will be cos of n. For beta will be substituting n pi, and again it will be cos of n pi. And we know that for n pi, cos has a maximum value and we are left with n only. And if we substitute this factor over here, we get, what do we get? We get this intensity I is equal to a naught square sine square alpha by alpha square, and we get only n square, right? So this is the intensity due to a single slit, if you recall the previous expressions. Therefore, the intensity due to n slits is actually proportional to n square. This is proportional to n square, right? Now for this, the corresponding phase difference, because you have put this beta is equal to n pi. You have obtained this condition by putting beta equal to n pi, right? By putting the limit beta to n pi. Now, let us find what is the corresponding path difference rather, right? So, beta was equal to pi by lambda e plus d sine theta, and you put that equal to n pi. Pi and pi goes. This path difference pd is equal to n lambda. So when the path difference between the subsequent waves is 0, 1, that's lambda, 2 lambda, you are going to obtain maxima. Now let us see what is the condition for minima. Let us go back to the equation, main equation, right? So here we will not like to repeat with the condition of indeterminacy again. If we want that the intensity should be 0, for that we need that sine square n beta should be 0, but sine beta should not be 0. So for minima, we can write, for minima, we want that sine n beta is equal to 0, but sine beta is not equal to 0. We don't want to land in the condition of indeterminacy again, right? We only have to find what is the condition of minima. Now, if we go with this, it implies that n beta should be equal to n pi, right? Because we know that sine is minimum for n pi values. Cos is maximum for n pi values, right? So from here, n for beta, again we can write it is e plus d sine theta pi by lambda is equal to n pi. So pi and pi will go. We are left with this path difference is equal to n lambda by capital N, right? Now to this n you can keep on giving values, that n is plus minus 1, plus minus 2, and I have told you that we cannot give n equal to 0 value to n, because n equal to 0 is already defined for the principal maxima. We can start giving values plus minus 1, plus minus 2, plus minus 3, and so on. Now, as you keep on giving values, so you get the path difference equal to lambda by n, 2 lambda by n, 3 lambda by n, right? But you cannot choose a condition like n lambda by n. Why? Because n and n goes, you are left with lambda, and lambda is a condition of maxima. So you have to stop at n minus 1, right? And then you can also carry on with n plus 1, n plus 2, but not n, because the path difference in terms of integral values of lambda actually correspond to maxima, right? And these values, they correspond to minima. So you can write that, you can write between any two principal maxima, there are n minus 1 minima. Remember it. And the intensity pattern on the screen is like this. So this is the central maxima. You have some minimas after it, again a maxima, again some minimas, again some maxima, again some minimas. Similarly on the left side, some minimas, again a maxima. But of course you have to ensure that the height of the central maximum is bigger than the adjacent maximas, right? And these are interspersed by these minimas, right? So this will be the intensity pattern of diffraction due to n slits. And I think that covers all important description about diffraction due to n slits. That's all.